Okay, hi everyone. Thank you all for joining to this tech talk about OAuth, OpenID Connect, and SHOT. I am Mariana. I'm a software engineer based in Buenos Aires.
I'm Agustin Luquez, also a software engineer based in Buenos Aires. Welcome, everybody.
So as we're both software engineers, that means that we work programming solutions for whatever is needed in our projects. And before we start with what this tech talk is about, we wanted to share with you how all of this came to life. So a few months ago, Agus and I were working on the same project, and we needed to program a solution for authentication and authorization. And what happened is that none of us really had much experience with this. So we decided to spend some time researching and also programming a few proofs of concept. And so that the way we could deliver a solution that was effective. And what you're gonna hear today is basically a compilation of everything that was useful for us, and hopefully it'll be useful for you too, so that you can understand what's happening behind the scenes with OAuth, OpenID Connect, and SHOT. So before we start, we're gonna just see a brief introduction of some of the concepts that we're gonna be mentioning throughout the presentation. First, it's important for us to understand the difference between authentication and authorization. So authentication is the process of verifying the user's identity. And it answers to one question, which is the user who he says he is? And on the other hand, authorization is the process of verifying what a user can and can't do. So it answers to a different question, that is this user allowed to do this? Here are some examples of authentication. In the picture, we can see username and password, which I'm very sure that we're all familiar with. And we can also see single sign-on with Facebook, Twitter, and Google. But there are other ways of authentication like Touch ID, Face ID, multi-factor authentication, and so on. Another concept that is pretty important, and I think we're all familiar too, is delegated authorization. We can see in this picture that Facebook is asking the user to access their location. And when some actor, like an app, a service, an API, a user, lets some other actor serve as their representative for a particular task, they are granting them delegated authorization. So in this case, the user is delegating authorization to Facebook. Now we're gonna talk a little bit about the evolution of authorization because it's nothing new, but we're gonna try to understand why some of the traditional methods are no longer suitable. So let's say we have a user that wants to use an application, and this application also wants to access an API on behalf of the user. How can we manage authorization here? One option is credentials sharing. Here, the user is asked for their username and password, so the application can log into the API on the user's behalf. And the problem here, there are many problems, but the one that's pretty obvious is that we're giving our credentials to this application. And this application can use them for whatever it wants, maybe to access the API, but maybe to change the password itself. So that's not pretty secure and it's not a great option. Then we have cookies. Here, the user is redirected off to the API where they can enter their credentials and get a cookie. But as we're using cookies, we are exposed to cross-site request forgery. So another option is API key. And here the user logs with a key that was given by the API. The problem here is that we're relying on the application to be able to securely store this API key somewhere. But if we have, for example, a single page application without a backend server, there's no way we can securely store this API key. So up until this point, we don't really have a good way to manage authorization. And that's where we're gonna start with OpenID Connect, with OAuth, sorry. So let's see what OAuth is. OAuth is an open standard protocol for authorization that works on HTTPS. And it's gonna decouple authentication from authorization by using access tokens, which we're gonna mention in a little bit. The important thing here to understand is that OAuth is gonna define some actors and the way they're gonna interact so that we can manage authorization. And also we can use OAuth to securely delegate access to devices, APIs, servers, applications, so it's pretty versatile. Now let's talk about access tokens. They are the permission to perform specific actions. So they basically represent the authorization that was granted. And we can think of them as keys to something that we do not own. With this key, we can access them, but we are not owners. Now, this is another concept, scope, that is pretty important. And then again, I think we're all familiar with this. In the picture, we can see that an application is asking to access the device's location. Location, in this case, is a scope, because the scope is the permission to do something in particular. And using them, we can grant scoped access. So each of the pop-ups that we can see here are different scopes, like the calendar, the contacts, record audio, all of them are different scopes. Now let's move on to the actors that are defined by OAuth. And let's see this with an example. If there's a user that has an Instagram account and wants that their pictures are also posted on Facebook, technically Instagram cannot access their Facebook account. So they're gonna have to ask for authorization. And if the user grants this authorization with an access token that is like a key, then Instagram is gonna be able to access Facebook. So let's see who the actors are here in this example. First, we have the resource owner, which is an entity that has access to a protected resource. We also have a client, that's an application making requests on behalf of the resource owner. And then we have a protected resource, that is something that cannot be accessed without the resource owner's permission. Now, the resource owner is not issuing this access token. He just wants to give permission, but there's gonna be another actor behind the scenes that's called the authorization server. And this server is the one that's gonna be actually issuing the access tokens and orchestrating all of this. And this authorization server provides two endpoints that we can use, the authorization endpoint and the token endpoint. The authorization endpoint is designed to interact with the resource owner. And here the authorization server is gonna verify the user's identity and it's going to be used to obtain an authorization grant. It's important to know that it is an HTTP GET method. And then we have the token endpoint, and this one is designed to interact with the client. And with it, we can obtain an access token by authorization grant or a refresh token. And this one is an HTTP post method. Let's see a little bit more about the authorization endpoint, the one to interact with the resource owner. This is what the request and response look like. And let's see a little bit about the parameters that we can send. So first we have the response type. With this, we're gonna define how the actors are gonna interact with each other. Then Aus is gonna tell us a little bit more about this. Then we have to send the client ID, that it's a string that defines our client. We have to send a redirect URI, and we can send scopes, that is what we talked about before, to define the level of access that we need. And also we can send a state, which is just a random string that we generate so that we can send it to the authorization server and then expect it back. And that way we can make sure that the one answering us is actually the authorization server. And on the response then, we're gonna get two things. First, an authorization code, which is not the access token, it's just a code. And then if we send the state, we're gonna get the state back. So the next step is the token endpoint. And there, in the request, we're gonna send again the grant type that's gonna define the flow that we're using. Then we're gonna send the code that we just received in the previous step. We're gonna send again a redirect URI, the client ID, and also a client secret that it's, as the word says, a secret and only the client knows this. So it's securely stored somewhere by the client. And on the response, we're gonna get finally the access token that we can use, and also some information about this access token, like when it expires and what token type it is. Also, if we configure it this way, we can get a refresh token that we can use to get a new access token once this one expires. And now Agus is gonna tell us a little bit more about this grant type, these flows, and how the actors can interact with each other. Agus.
Thank you, Mar. The term grant type refers, as Mariana said, to the way an application gets this access token. OAuth defines several grant types, and extensions can also define new grant types. Each grant type is optimized for a particular use case, whether that is a web app, a native app, mobile app without the ability to launch a web browser, etc. Server-to-server application also. And we are going to see each grant type, what are they for, how do they work, and finally some recommendations. Here in the slide, you can see all the grant types defined, implemented by OAuth. And it's important to mention that some of them are legacy ones, some of them have already known vulnerabilities. So while I'll explain each of them, I will mention these particular things. The first grant type we are going to see is the authorization code grant type. This grant type was designed to be used from clients that are able to keep a secret. We are going to call this client confidential clients, and these are web apps and mobile apps with the backend. As you can see in the the first high-level step, the application opens a browser. This grant type differs from most of the other grant types because it has an initial authorization request, as that Mariana told us about, the authorization endpoint, that where the user authenticates and authorizes our application. The user will be redirected back to the application with this authorization grant represented by this authorization code, and the application will exchange the authorization code for an access token with the request to the token endpoint. We will see in detail in the next slide. As you can see, the client will redirect the resource owner to the authorization endpoint with the response type value set to code. That means that we are going to use the authorization code flow. And it will send another parameters along with the client ID, that it will be the redirect URI, indicating where the authorization server needs to send the authorization code when the authentication is validated. After the user interacts with the authorization server, it will be redirect the authorization code to the client in the response. Now the client needs to instantly send the authorization code to the server. We will see later why it has to be instantly. And as it is a post request, it will include its credentials along with the grant type authorization code. Now the server will validate this code and return back the access token. And this is the access token that the client will use later for each request to the protected resource to access it. It's important to mention that the protected resource trusts the authorization server and trusts that this access token is a valid one. What's happened now when the client cannot store a secret? We will call these clients public clients. They are mainly JavaScript applications. This flow, the implicit flow, came to light to make this happen. Looking deeper in the next slide, we will see the flow where the client application also, as before, redirect the users to the authorization server. But now the authorization server will validate the user credential, of course. The user will authenticate and authorize the client, but it will not return the authorization code. It will return the access token itself, though. Now, with this access token, we will use this for the protected resource access. You might be thinking that it might be more insecure, and it's right. You are right. Later, we will see why this flow is legacy and why what are the vulnerabilities it has. Well, talking about insecure flows, here we have the resource owner password credential, aka password flow. That is, this flow was designed for quickly migrating applications to use OAuth, to implement OAuth. So you should use this as a temporary solution. As you can see in the slide, the resource owner has a trust relationship with the client. So you should never use this flow with third-party application. As you can see in the high-level steps, basically the client will bypasses the user credentials along with its credentials to get the token, the access token. I will not spend too much time in this flow because, as I said, you should never use it. It's just a temporary solution. But you can see that it's just simply a call to the token endpoint to get the access token. And the grant type value will be set as with password. Going to the next flow, it's the client credential flow. This flow was designed for all these scenarios where there is no user involved. So the client application is the resource owner itself. And of course, it's a confidential client because it has to store his secrets, his credentials. Now the next, we'll see the flow that is basically a call to token endpoint with credentials and get the access token in return. The grant type will be set, as you guess, client credential. Yeah, the next flow was designed for devices with no browser. That means that devices that hasn't got the ability to open a browser. That are the smart TVs, printers, etc., and all the nowadays known Internet of Things. I will not spend too much time in this flow neither because it's an extension of OAuth, and it has also another new endpoint. It basically consists in delegating the authentication to a trust device that usually will be your smartphone. The next flow is the refresh token. You might know that access token has expiration time. So what happens when the token expires? Well, we have this grant type called refresh token that will renew your access token. To get this refresh token in the authorization endpoint, you will add a new scope, and the authorization server will know that the client needs the refresh token, and the client will use this token without asking the user to re-authenticate every half hour or every hour. Well, we are talking about security, so we might know that there is constantly changes because vulnerabilities appears every time. Now we are going to talk about some vulnerabilities and no vulnerabilities in OAuth, and we will start with the implicit flow. Well, as we said before, the access token will be will travel in the URL because it will be returned in the authorization endpoint that it is a get request, and it of course is very insecure. And also the client has to store this token in the browser. It's also very insecure. But it is important to mention that at the beginning of JavaScript applications, JavaScript application couldn't make a request to a different server, a different domain, and the authorization server is in a different domain. So that's why this flow appears. But nowadays, the cross-origin resource sharing, as known as CORS, is universally adopted, and nowadays JavaScript application can make post requests to another domain, cross-origin request. So there is no excuse to use this flow instead of the authorization code flow. But also in the next slide, we will see that what appears to be the most secure flow, the authorization code flow, was corrupt. These attacks, called authorization code interception attack, consist in a malicious client stealing our authorization code, because the authorization code will travel in the URL. So when the malicious client steals our authorization code, it can call the token endpoint and get our access token endpoint. But fortunately, we have a solution here. In the next slide, we will see that this is called PIXI. PIXI appears as an extension to this authorization code flow, and it securely performs the OAuth exchange from public clients. You can also use it with confidential clients, we will see later, but it appears to help the public client to make secure authorization. How does PIXI work? Well, it's very simple. It will use a cryptographically random generated code called code verifier, and also it hash value called code challenge. We will see in the next slide how it works. The flow will not change. It will be basically an authorization code flow, but it will include new parameters. Here, when the client redirects the user to the authorization server, it will generate a code verifier randomly and will use a hash method to hash this code verifier and generate a code challenge. This code challenge method and code challenge will be sent to the authorization server, and the code verifier will be saved for later use. The authorization server will save the code challenge method and the code verifier also for later use. When all the authentication and the authorization run, the server will redirect to the client with the authorization code, and now the token endpoint call is made, but now it will be sent, the client will be sent the code verifier. With this code verifier, the authorization server can validate this code, because it will hash the code verifier with the method and will compare to the code challenge we sent before. If everything okay, we'll return back the access token and the flow will continue as usual. Well, I mostly said, Marian, can you pass to the, yeah. I mostly said what are the grant types recommended for each scenario by OAuth, but as you hear, many extensions have appeared since 2012 when OAuth 2.0 was published. So a new protocol that is still in draft mode is consolidating all this stuff, and it has the name as OAuth 2.1. It's a completely new protocol. And for example, it makes the implicit flow that I told before, and the password flow, legacy flows, that we shouldn't use it anymore. there will be no more access tokens in the URLs, and the PIXI will be mandatory every time we will use the authorization code flow, and many more things that you can read it about. Now, Marian will talk about OpenID Connect. Marian.
Yeah, thank you. So now that we kind of understand what OAuth is and how we can use it to manage authorization, we have to think about authentication, because we mentioned it, but we didn't really say how we're going to manage it. And that's simply because OAuth doesn't say anything regarding authentication, and that's where OpenID Connect appears. So OpenID Connect is an authentication protocol that is built on top of OAuth 2.0. So it's not going to change anything already defined by OAuth, but it's just going to add another layer so that we can manage authentication. So basically OpenID Connect is OAuth 2.0 plus an identity and an authentication layer. So it's going to make our authorization server also an identity provider. And the good thing about OpenID Connect is that we can use it for all client types. Now, there are a lot of features that OpenID Connect provides, and we're just gonna see the main ones. So OpenID Connect standardizes cryptography and validation procedures with token types. It also defines a new token, the identity token, that describes the authentication event itself, and it's intended for the client application. The format of this token, it's a JSON Web Token signed with a private key. And we're gonna talk about JSON Web Tokens in just a little bit. OpenID Connect also provides a well-known endpoint, and there we can find documentation that describes the OpenID provider. So we can know which scopes and claim types are supported, we can know the public key for verifying tokens, and some other information. OpenID Connect also defines a user info endpoint that we can access sending an access token, and it's gonna return some scope claims about the delegating user. There's also a new flow that OpenID Connect defines that is called hybrid flow, and it's going to add some extra combinations using this identity token that OpenID Connect also defines. And lastly, there are some claims that we can use, some standard default claims, so it's easier for us to manage authorization and authentication. Now, we're not gonna see too much more about OpenID Connect, just because the important part to understand as programmers is that we can use OpenID Connect and OAuth together, and that way we're going to be able to manage authentication and also authorization. Now, we mentioned JSON Web Tokens, so that's the next thing that we're gonna try to understand. So JWT, that it's pronounced short, and it's short for JSON Web Tokens, it's a standard for safely passing claims that nowadays is supported by all major frameworks. And that's because of its simplicity, compactness, and usability. And this is how a JSON Web Token looks like. We're gonna try to understand what all these letters means. So here we have three elements that are separated by dots. The first element is called header. The second element is the payload. And in this case, we have a signature, but there are different things that we can use at the end of the JSON Web Token that we're gonna talk a little bit about in a few slides. It's important to know that both the header and the payload are JSON objects, and that's what we are gonna be focusing on. So the header. If we decode it, we get a JSON, as I said before, and the header is gonna give us information about the JSON Web Token itself. So depending on how the format of this token is, some different claims are gonna be mandatory here. So in this case, we have the algorithm in use for signing and or decrypting this shot, and we also have the token type. Now, the second part is the important part for us, and it's where we're gonna find all the interesting information about the user. And if we decode it, it looks like this in this case. And there are two types of claims that we can find here. There are registered claims and also custom claims. None of them are mandatory, but registered claims have some meaning behind them. So if we use them, we have to use them properly. So in this case, we have two registered claims, the subject and the issued at claim that tells us when this access token was issued at. And also we have a custom claim that, as you can guess, it's the name Shandao. And the last part of the JSON Web Token, as I said before, is in this case a signature, but there are two other ways we can use the JSON Web Tokens. OpenID Connect uses this way with a signature, but just so you know, we can have unsecure JSON Web Tokens that just don't have this element. And we can have encryption data here. So instead of one element, we're gonna have three: the initialization vector, the encrypted data, and the authentication tag. But as I said before, the important part is the payload. Then there is where we're gonna find all the information that we can use to authenticate and authorize our user. Now, all this theory is gonna be used in a demo. So AUS is gonna show us how all of this actually works together and how it's not something that we have to program too much. We just have to configure a few things, but we're gonna see how all of these work together. So I'll let you share your screen.
Thank you. Well, can you see it? Okay. Well, we have prepared a demo of what is the recommended grant type, the recommended flow for most of the scenarios. That is the authorization code flow plus PIXI using OpenID Connect 2. And well, as a reminder, I will post here the flow. You can see that the client redirect the user to the authorization server. It will log in. The authorization server will return back the authorization code to the client. The client will send the authorization code to the token endpoint and will receive the access token that will be used in each request. That's all. We can also mention that using PIXI in the authorization endpoint, we have to send these two parameters, and in the token endpoint, the code verifier. Well, let's go to the demo. Here we have in the port 8080 KeyClock. What is KeyClock? KeyClock is a software that provides us an authorization server, right? Basically. Here we define the client called Angular Demo App, and it will be public. So you can see that a public client can securely perform the authentication and authorization. And the standard flow enabled, that it is, as you can see, the authorization code flow. And here we have in the port 4200, an Angular app that will perform the login with a simple login. Here I have open a notepad, so I will be pasting all the stuff. And first of all, I want to show you that here, when we first enter the page, there is a get request to the KeyClock, the authorization server, to the well-known endpoint that Marian told us about, that is a part of OpenID Connect. And you can see that here we have the authorization endpoint, the token endpoint, some of the stuff OpenID Connect provide us. Well, when the user wants to log in, the client will redirect the user to the authorization server, sending with the get request, sending a few parameters. Here I will copy these parameters so we can see it. We can see them better. And if the response type equals to code, that means that we are going to use the authorization code flow. Client ID, the state that Marian told us about, that it will be echoed later by the authorization server for security reasons. The redirect URI, that it is the home page of our Angular application scope. And here is the code challenge, that it is the hash value of the code verifier using this method. The authorization server will save these two values for later use. Well, now when the user logs into the application and authorize the client, we can see that it will send to the authorization server the username and the password. This is not my bank account password, don't worry. And the authorization server will validate it, and if everything is okay, will redirect the user. This code is for redirect. Will redirect the user to the Angular application, sending the state that, as you can see, is the same as here. So the client knows that we are all okay, and the code, the authorization code, I will be pasted here. This code, as you know, will be used in the token endpoint to send to the authorization server. Here is the token endpoint. As you can see, it is a post endpoint, so there is no query parameters. All the parameters are in the form data, and I will copy it to see it better. Here, we are sending the authorization code. As you can see, it's the same as here, and a few parameters along with the code verifier. This code verifier, the authorization server will hash with this method and will compare with this code challenge. If everything is okay, will return us the access token and the ID token if we need it, and also the refresh token if we ask for. And that's all. Also, then this application will call the user info endpoint that OpenID provides us. And as Mariana said, it is a protected endpoint. So the client needs to include the token, the access token, in the header. And this endpoint will provide us all the claims. Here you can see these registered claims that the OpenID provides, and also some custom claims like the age. And that's all for the demo. I hope you have now a better understanding of how a login and all the authorization and authentication happens, all the magic behind the simple login. And now we are going to answer some questions. You have our emails in the slide though, so you can ask any questions later if you want. Meanwhile, I can show you that this is the Angular application. We are using this Angular OAuth OpenID Connect library, and all this library needs to work is where the authorization server is, the redirect URI, client ID, response type, telling the flow, and that's all. So here you can see that it is a very standard flow, and you don't need to custom a lot because it is quite standard.
Okay, if there are no questions, thank you all for joining. Hope you have a good day. And then again, if you have a question later on the week, you can just send us an email.
There is a question in the Q&A model.
Oh, yeah, okay, let me see. Can you tell us the timeline these technologies evolve OAuth and towards PIXI? So OAuth was created on 2012, and I think PIXI has about 2 years, but it hasn't been integrated on OAuth yet. So it's like an extension that was created, and hopefully in OAuth 1 and later versions is going to be included. As you could see in the code that I was showed, we could use PIXI with a standard library. So it's pretty much a standard, even though it hasn't been integrated on a new version of OAuth. So it took a few years to break the authorization code flow, but these things happen in technology all the time. So it's very common, and probably there are going to be newer versions with different flows that are going to be more secure.
And also it's important to mention that maybe new vulnerabilities will appear and a new flow will come to light because these secure things will always change it. Will be changing. Well, I think we can close the presentation. Right?
Thank you, guys. Great talk.
Thank you.
Bye.
Bye-bye.
Thank you. Bye, guys.